Okay, so today has more to do with, why is this so big? I just wanted to make it smaller. Probably going the wrong way. Let's see if I could pull this up. Maybe that would help. Grab my whole screen. Hope I didn't make you sick. All right, so here we go. So now we're applying the system. So we have had two equations and we've graphed them to find their, if they intersect and have one solution. We have found that if we graph and they overlap, it's an unlimited amount of solutions, an infinite many. If they end up being parallel, they could have no solutions. We have used substitution. We have used elimination with addition. And then we have used elimination by multiplying. So you almost have to choose what is the best method. Then we're going to talk a little bit about how this is applied to real life. Okay, so here we go. So choosing a best method for applying systems where you have two equations. So remember your solution is an XY ordered pair or a no solution or infinite many solutions. So graphing, if you make your equations look like this and graph them, you can probably see the answer. It may not give an exact answer, but if you're on Desmos, it will. It will, as long as you're clicking on the right spot. Substitution. That's when we had our equation either y equals or x equals, and then we substituted these values into the other equation. Elimination by addition. So if one variable is the opposite of the other, they would cancel one of them out. And elimination by multiplication is if none of the above works, multiply by a value to create opposites, including maybe even a negative sign. And I showed you that yesterday. So on here, if I look here, we're not going to solve this. So we're just going to say, what method would you use? So quickly, you should see these would cancel out. So that one, elimination by addition, so we would just cancel that out. So we would say elimination by addition. This one here, it says x equals. So we would take that x equals and put it in here. So that would be substitution. And then this last one, if and only if this became a negative 2y and multiply this first thing, everything by a negative 2, we could get there. So this is called elimination by multiplication. Okay, so choosing the best method. Okay, next, word problems. I think they rank up there with fractions. You guys just don't like them. You guys freak out when you see them. So here we go. We're going to try to make this easy. And these are going to be kind of the same thing. So when this is a system, you're going to have two equations. Systems, two equations. We're not going to solve these. We're going to write them. So the cost of 5 squash, 2 zucchinis equals this. So 5 squash plus 2 zucchinis equals that. 3 squash, 1 zucchini cost this. 3 squash plus 1 zucchini equals 0.75. Now, we could actually solve this system and solve how much does it cost for your zucchinis and your squashes. So on this one, if you looked, I would say I would have to use elimination by multiplication because I would want to multiply this by probably a negative 2, this whole thing. So elimination by multiplication, or you could graph it out to see how much they cost, each vegetable. Next one. The talent show committee sold a total of 530 tickets in advance. Student tickets cost this, so $3 per student ticket, and adult tickets, $4 for adult tickets. All right. If the total receipts, let's see, this is tickets, right? The students' tickets cost, the total receipts were. So student tickets plus adult tickets was a total of 530 tickets. Both of these together equaled this amount. And then again, I could multiply this, graph it or multiply this by maybe a -3 and solve for how many student tickets or how many adult tickets were sold. So again, elimination by multiplication is how I could solve that. Or graph on Desmos. Okay. Next one, Rob had 40 coins, dimes and quarters. So dimes plus quarters equals 40 coins. And it was worth this many cents. So 10 cents, 0.10 for dime, plus 0.25 for a quarter is equal $7.60. Again, elimination by multiplication or graph using Desmos. And that's what we're doing. These are a little bit harder and it just takes some practice. So don't freak out, they're word problems. You can do it. All right, I'm looking back here. I think we have one more thing, but I think this is it before spring break. So we'll have another quiz, and then it's off for Pi Day or Amnesty Day, and then spring break. So anyway,